Okay, students. I'm going to continue with the extra questions related to chapter 16 of your grade 10 science textbook, that is changes of matter. And here I will continue with the questions. Extra question 23. Apparatus used to collect oxygen gas in the laboratory is shown in the diagram given below. Label the parts A to H. So, if we look at the diagram first, you can see A here, it points to beehive shelf. Then you have the trough containing water. So, B is the trough containing water. C, you can see it is the gas jar. And D is the collected gas. So, here since they have said oxygen gas, we can write it as oxygen gas. Then E is the delivery tube. It points to this tube, the delivery tube. And F, you can see, points to the stopper. It can be the cork stopper or the rubber stopper. We can write it as cork stopper. Normally for boiling, heating, cork stopper is more better, but we do use the rubber stopper as well. Then G has to be the boiling tube. It has to be a boiling tube. And here you can see, since it is oxygen gas and the solid is purple in color, you all know it is potassium permanganate crystals. So, those are the parts that you need to label now. So, here A we identified as beehive shelf. Beehive shelf. Then what is B? Trough with water. Trough with water. Then C, there we have C, that is the gas jar. Gas jar. Then D we identified it as oxygen gas. Then E is the delivery tube. Then we have F is the stopper. I'll put it as cork in brackets. Then G, we have the boiling tube. And H should be crystals of potassium permanganate. Of potassium permanganate. So, those are the parts. A, beehive shelf, then B, trough with water, C, gas jar, D, oxygen gas, delivery tube is E, F is the stopper, then G is the boiling tube, and H is the crystals of potassium permanganate. So, like these students, you should be able to identify the parts and label the parts when they give you the apparatus. With that, we'll move on to the next question. So, like always you do, students, I'm sure you will also answer all these questions by yourself first, and then you will listen to my discussion. Extra question 24. A group of grade 10 students carried out the following activities in the laboratory. So, here you can see there are test tubes given. So, into these pieces of copper, there is dilute HCl, P. Again dilute HCl, that is Q, pieces of magnesium. R, copper sulfate solution and pieces of zinc. S, copper sulfate solution and pieces of silver. So, different metals, P and Q the same solution, R and S also same solution. So, we will see what happens there. Write the letter relevant to the setup where you can observe the changes given below. So, first we will try to understand the changes that take place here. Now, if we put a piece of copper into dilute HCl, will there be a reaction? No. Copper does not react with dilute hydrochloric acid or dilute sulfuric acid. Why? It is below hydrogen in the activity series. So, it will not displace hydrogen. Copper is below hydrogen in the activity series. There will be no change here. But when magnesium is put into hydrochloric acid, hydrogen will evolve. So, you will see the liberation of gas bubbles and the dissolving of magnesium. Then here, zinc into copper sulfate. Now, zinc is above copper in the activity series, so zinc can displace copper. So, the blue color of copper sulfate solution will decrease. You will see the copper depositing, brown color deposit, and also you can observe the zinc dissolving. Here, silver and copper sulfate solution. Silver is below copper. So, silver cannot displace copper from its solution. Here also no change. Here no change. Here also no change. But the other two, you will see changes. Write the letter relevant to the setup where you can observe the changes given below. Deposit of a brown color solid, where will that happen? It will happen here. That is going to be in R. Liberation of gas bubbles, you will see that here, Q. Decrease in color of the solution, that also you will see here, R. Is that okay, students? So, we discussed the observations. You are able to write the setup that is relevant to these observations. I will move on to the next one. Second question, the same diagram is given to you, so I am not going into detail there. Write the conclusion from observations P and Q. Observations P and Q. Copper does not react with dilute hydrochloric acid, but magnesium reacts with dilute hydrochloric acid. So, copper doesn't react with dilute HCl, but magnesium reacts with dilute HCl and liberates H2 gas. Then the third one, explain the observations of R and S. R and S. Now, copper sulfate, copper is displaced by zinc because zinc is more reactive than copper. And in the next one, S, silver does not displace copper because it is less reactive than copper. So, that is what you have to explain here. In R, zinc is more reactive than copper. That is why zinc displaces copper from copper sulfate solution. So, in S, silver is less reactive than copper. That is why silver cannot displace copper from copper sulfate. So, there is no reaction. So, is that okay, student? In R, zinc is more reactive than copper. That is why zinc displaces copper from copper sulfate solution. And in S, silver is less reactive than copper. That is why silver cannot displace copper from copper sulfate. So, there is no reaction observed. Is that clear? So, here they wanted you to write the conclusion from the observation. So, there you said copper doesn't react with dilute hydrochloric acid. But magnesium reacts with dilute hydrochloric acid and liberates hydrogen gas. If you want, you can even also say the tendency of copper to react with dilute hydrochloric acid is very less or no tendency at all, whereas magnesium reacts better with dilute hydrochloric acid. So that also can be written there. But here I have given the conclusion. I am sure you can understand that, students. With that, we will move on to the next one. Fourth one, write balanced chemical equations for the reactions taking place in the above activity. So, one reaction took place here. What is that? Magnesium with HCl gives rise to magnesium chloride and H2 gas. Now, you are very familiar with balancing because 2 chlorines and 2 hydrogens, we put it as 2 HCl. You can remember that. Magnesium 1, 1, 2H, 2H, 2 chlorines, 2 chlorines. So, that is the balanced equation. Then, there is reaction here. Zinc plus copper sulfate gives rise to zinc sulfate and copper. Look at the reaction. 1 zinc, 1 zinc, 1 copper, 1 copper, SO4 and SO4. So, the reaction is already balanced. So, they want you to write balanced chemical equations for the reactions taking place in the above activity. Other two, there are no reactions. If we want, we can put this as, this is Q and this is R. So, in only those two, there are reactions. In the other ones, there are no reactions. Q and R only. Then the next one. Find the mass of hydrogen evolved when 3 moles of magnesium completely reacts with the acid. So, this is again related to balancing equations. We have already written the balanced equation. I will write it again. 2HCl gives rise to MgCl2 plus H2. So, how do we use this information to calculate? Now, here when you have 1 magnesium, you need 2 HCl, 1 MgCl2 and 1 H2 are produced. So, here find the mass of hydrogen evolved when 3 moles of magnesium. So, if you have 3 moles, how much of H2 will be produced? 1 Mg, 1 H2. So, 3 moles of Mg, this has to be also 3 moles. So, here find the mass of hydrogen evolved when 3 moles of magnesium completely reacts with the acid. So, 3 moles of hydrogen will be evolved. So, to find the mass, what do? You know the equation, moles equals mass over molar mass. So, if you rearrange, mass is equal to moles into molar mass. So, we know the number of moles, 3 moles. We need to calculate the molar mass. Hydrogen is 1. Molar mass of hydrogen, H2 is what? 2 into 1. That is going to be 2 grams per mole. So, if we find the mass of hydrogen, H2, what is that going to be? Moles into molar mass. You can remember the symbols as well, students. N is moles, this is moles, and molar mass is capital M, mass into molar mass. So, that will be number of moles 3 into 2 grams per mole. So, that will be 6 grams. 3 moles into 2 grams per mole, the answer will be 6 grams. That is the mass of hydrogen that is evolved. So, what do? We use the balanced equation. Magnesium is to hydrogen is 1:1. So, if there are 3 moles of magnesium completely reacts, then you will get 3 moles of hydrogen. So to find that, we use the equation moles equals mass over molar mass. Mass is moles into molar mass. To do that, we find the molar mass of hydrogen, that is 2 grams per mole, and using that, we already know we need 3 moles of hydrogen into 2 grams per mole. The answer is 6 grams. Is that okay, student? So that is how you do the calculation. With that, I will move on to the next slide. Extra question 25. 3 methods used to collect gases in the laboratory are given below. So look at the methods. A, you can see it is the upward displacement of air. Here you can see B, downward displacement of air, and C, you can see it is the downward displacement of water. Methods used to collect gases in the laboratory are shown above. Identify the methods. That's what I just did. So here A is upward displacement of air, then B, you can see downward displacement of air, and the last one C, downward displacement of water. Placement of water. So those are the 3 methods: upward displacement of air, downward displacement of air, downward displacement of water. With that, we'll move on to the next question. Write the gases evolved in the following instances. Write the method suitable to collect the gas evolved in each of the reaction given below. So decomposition of hydrogen peroxide. What is the gas evolved there? It is going to be oxygen. And what is the suitable method? Can we use A or B? Normally we don't. We use method C. So here it is C. Downward displacement of water is used to collect oxygen gas. Second one, reaction of magnesium with dilute sulfuric acid. You all can remember that. Metal with an acid, hydrogen gas is evolved. So here it is going to be hydrogen gas. Hydrogen gas. What are the methods? One thing, we can use downward displacement of water, C. Then you can remember, students, hydrogen is less denser than air. So that can be collected by downward displacement of air. That is B here. So both methods B and C can be used to collect hydrogen gas. Then the next one, reaction of eggshells with dilute hydrochloric acid. Eggshells, what is it? Calcium carbonate. With dilute hydrochloric acid, it will evolve carbon dioxide. So carbon dioxide gas. Again, we can collect it using downward displacement of water like we normally do. And also you can remember, carbon dioxide is more denser than air. So that can be collected by upward displacement of air. The first one, A. Upward displacement of air can be used to collect carbon dioxide. So oxygen, downward displacement of water. Hydrogen, downward displacement of water and downward displacement of air. Carbon dioxide, downward displacement of water, upward displacement of air. So those are the methods. I am sure you were able to identify the gases correctly and also the relevant methods correctly. With that, students, I am going to move on to the next slide. Here I have extra question 26. A blast furnace used to extract iron is shown below. So you can look at the diagram here, students. This is slightly different from what we have already seen. You can see the diagram. Now here A is the mixture of raw materials. There is the waste gas going out. B is the top layer taken out. So it's the slag out. C, you know, is the bottom opening. So it has to be the molten iron out. So Y has to be molten iron or liquid iron. X has to be slag. X is slag. Usually slag is over molten iron. And D is the hot air blast. So we have looked at the diagram. All the reactions take place within this blast furnace. Questions. First one, identify the components denoted by A, B, C and D. A, what is it? The raw material. Mixture of raw materials. Mixture of raw materials. Then what is B? B we identified as slag out. Then C, what is C? C is the iron out. I have told you all students, the position is important, not the side. It can be on different sides, opposite sides or the same side, up and down. Position is important. Top is slag, bottom is iron. And D is the hot air blast. Hot air blast. So we have identified the parts. Then the second one. The temperature range in the furnace is between 1000 degrees Celsius and 1900 degrees Celsius. Write a reaction that causes this high temperature. You can remember students one thing, hot air blast. But in addition to that, when carbon coke burns with oxygen, it releases lot of heat energy. So they want you to write the reaction. So the reaction between coke and oxygen forming carbon dioxide. This produces or releases a large amount of heat energy. That is what you need to write here. With that, students, we'll move on to the next slide. Carbon monoxide reduces iron from its ore. Write the iron ore used in the above. We need to write the iron ore that is used in the above, that is hematite. You can remember, students. Hematite. We have answered similar questions before. It has Fe2O3. You need to write hematite. Write the reactions that lead to the formation of carbon monoxide. Write the reactions that lead to the formation of carbon monoxide. How do we get it? Carbon reacts with oxygen forming carbon dioxide. Then carbon dioxide reacts with carbon to form carbon monoxide. So we need to balance it. Is that okay? So write the reactions. Carbon and oxygen gives carbon dioxide. Then carbon dioxide reacts with carbon to form carbon monoxide. Then the third one. Write the balanced chemical equation for the reduction of iron from its ore. You are familiar with that also. Reduction of iron. Fe2O3 is the iron ore. Reducing agent is carbon monoxide. Gives rise to iron plus carbon dioxide. When we balanced it, these two are 3 and that is 2. Fe2O3 plus 3CO gives rise to 2Fe plus 3CO2. That is the balanced chemical equation. So I am sure students you were able to answer all these questions. You were able to write all these balanced equations correctly without any problem. So with that, students, I will move on to the next slide. Extra question 27. An activity carried out by a group of students to compare the reactivity of metals X, Y and Z with dilute hydrochloric acid is shown below. So we have seen these types of reactions in the lab. So you are familiar with the reaction of metals with acids. The rate of fizzing was observed and tabulated as given below. So here to compare the rate of reaction or the tendency of the metals to react with the dilute acid, they have compared or observed the rate of fizzing. So if you look at the activity, now here you can see dilute hydrochloric acid, equal volumes of dilute hydrochloric acid has been taken into 3 test tubes and the different metals, metal X, metal Y and metal Z are added to those 3 test tubes. And here we have the table. So here they have given the metals again X, Y and Z and rate of fizzing. So you can see here X very slow. So the reaction is slow. Metal X reacts slowly with dilute HCl. Y reaction is fast. And there Z no change was observed. So that means the metal Z does not react with dilute hydrochloric acid. Now try to recall the reactions that we discussed. When you take the metals magnesium, zinc, aluminium, they react fast with dilute hydrochloric acid. Whereas if you take iron, iron reacts very slowly with dilute hydrochloric acid. You were able to see that when we did the activity in the lab also. But how about copper? When we put copper metal into dilute hydrochloric acid, there is no reaction. I told you all that before also, even if you leave it for a day or 2 days, still the reaction will not take place. That means copper doesn't react with dilute hydrochloric acid. Why is that? You know the reason also. Now if we take the activity series, recall the metals, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, then we have hydrogen, then we have copper. So there copper is below hydrogen. Normally a metal that is above in the activity series will displace another metal from its salt solution. So if you take HCl, H is there but copper is below H. So because of that, copper cannot displace hydrogen from HCl. So that is why copper doesn't react. So this can be either copper or any metal below that. And here if you remember, very slow. So most likely it will be iron. And very fast or fast reaction, it can be either magnesium, aluminium or even zinc. You should try to relate the observations that you have seen with the observations given here. Then it is easy to understand the question. So the first one. Arrange the metals X, Y and Z in ascending order of reactivity. What is ascending order? Ascending order is increasing order. You all can remember students, if we take the activity series, that is in the descending order. So that means decreasing order of reactivity. That is why potassium, sodium very highly reactive. Whereas platinum, gold very less reactive. But here they want you to arrange them in ascending order. Always when you read the question, look at that carefully. Whether it is ascending or descending, increasing or decreasing. So here it is ascending order of reactivity. What is the order? Now Z, no change was observed. So the slowest one is this, or least reactive out of the 3 is Z. Then you can see X is very slow. So that is the next most reactive element and Y reacts fast. So that has the highest reactivity. So if we are to arrange them in ascending order of reactivity, it will be Z, then we will have X and then we will have Y. Is that clear to you all? So rate of fizzing is related to the ability or the tendency of the metal to react with the acid. If the rate of fizzing is fast, tendency of reaction is fast, that means the reactivity is high. So Y shows the highest reactivity, whereas Z shows the lowest reactivity. Is that clear to you? So with that, we'll move on to the next part. Again, the pictures and the table are given to you. We have already discussed that. Second part of the question, identify X, Y and Z if the metals used are aluminium, iron and copper. So I already told you all. Now if it is a very slow reaction, it has to be iron. Now this will be iron. So Y, we said it can be magnesium, zinc or aluminium. So here they have given aluminium. And Z, there is no change. Copper doesn't react with dilute acid. So this will be copper. So this is what we need to do. Identify X, Y and Z if the metals used are aluminium, iron and copper. So X is going to be iron. Then Y is aluminium. And Z is copper. So we have identified the 3 metals. Then the third one. Write the balanced chemical equation for the reaction of aluminium with dilute hydrochloric acid. only for the reaction of aluminium with dilute hydrochloric acid. So aluminium is Al, dilute hydrochloric acid, HCl. What are the products? It gives the salt and evolves hydrogen gas. So AlCl3 plus H2 gas. We need to balance this. How do we do that? Now aluminium is balanced. Hydrogen, there's one. There are 2 hydrogen atoms on the product side. Chlorine, there is 1, but there are 3 chlorine. So when you see the values 2 and 3, you all know by now. What do we use? The least common multiple. Least common multiple of 2 and 3, 6. So we have to have a total of 6 atoms there. So to do that, we can put a 2 here and we can put a 3 there. So 2 into 3, 6 chloride ions, and 3 into 2, 6 hydrogen atoms. So then we will need to have 6 HCl, 6 hydrogen, 6 chlorine. But now aluminium is also 2 there. So we will need to put a coefficient 2 here. 2 aluminium plus 6 hydrochloric acid gives rise to 2 aluminium chloride and 3 hydrogen gas. So that is the balanced chemical equation for the reaction of aluminium with dilute hydrochloric acid. So I am sure students, you also would have written it correctly. With that, we'll move on to the next one. Again, the same question, part 4. So we have already discussed the diagram, the activity and the observation. What is the gas liberated in the above activity? So just now we wrote the equation. What is the gas liberated? It is hydrogen gas. So you can either write it as hydrogen gas, or you can write it as H2 gas, H2, and put the physical state as G. Anything is fine. Fifth one. Write a suitable method used to collect this gas in the laboratory. How do we collect hydrogen gas? When we did all the activities, what was the method? We used the downward displacement of water. But you all know for hydrogen, because it is the lightest gas, it is lighter than air also. So we can collect it by the downward displacement of air. So you can write any one of the 2 methods. Downward displacement of water, downward displacement of air. So write a suitable method used to collect this gas in the laboratory. I will write downward displacement of air. We have done the activity with the downward displacement of water, and I showed you all how we can do downward displacement of air as well. So you are familiar with that method. Then the next one. Write 2 uses of the gas mentioned above. So 2 uses of hydrogen. You are familiar with many uses. What are they? Now in the production of margarine, manufacture of margarine, we use hydrogen. Then to produce ammonia by reacting hydrogen gas with nitrogen gas. Then we get ammonia, and that ammonia is used to do what? Used to produce urea or ammonium fertilizers. So for that also we use hydrogen. Then hydrogen, because it is a combustible gas, it is used as the rocket fuel for rockets. And also when we carry out reduction reactions in organic chemistry, to reduce organic molecules, we can use hydrogen. So those are the uses of hydrogen gas. Even we use hydrogen to fill balloons. That also you all know. So we can write any 2 of those uses here. So I will say manufacture of margarine, and used as rocket fuel. So it can be either manufacture of margarine or used as rocket fuel, any one of the 2. You can write the other uses as well. Producing ammonia, producing urea, that is fertilizer, or used in reduction reactions related to organic compound. So all those are the uses of hydrogen. With that, students, now we'll go on to the next question. That is extra question 28. Part of the activity series is given below. So here you can see on the side, you can see the part of the activity series. Potassium, then they have not given the next metal. Then there is calcium, then the other one is B, then aluminium, then C, D and Sn. Sn is tin. So if you write the elements there, potassium, sodium, then calcium, magnesium, aluminium, then we have zinc, iron, tin, like that it goes on. So you're familiar with all the metals in the activity series. And I'm sure by now you all know the full activity series by heart. So then we will look at the questions. Write 2 reactions that were considered when preparing this activity series. That also you all know because we did all those reactions as examples in the laboratory. What are the reactions? Reaction of metals with oxygen, reaction of metals with water. When we say water, cool water, hot water and steam. Then we saw the reaction of metals with acids. Dilute hydrochloric acid, dilute sulfuric acid. And also we saw the displacement reaction. Zinc reacting with copper sulfate and displacing copper, but copper does not displace zinc from the zinc sulfate solution. So those are the reactions we have observed and discussed. In addition to that, you all know they consider many other properties and then only they have arranged these metals in the activity series according to the descending order of reactivity. That is the decreasing order of reactivity. Is that clear, students? So then, they want us to write 2 reactions that were considered when preparing this activity series. So you can write any 2 reactions. I will say reaction with air, then reaction with water. So you can also say reaction with dilute acids and displacement reactions. Those are also correct. Then the second one, identify the metals A, B and C. So we have already identified them. What is A? A is sodium. What is B? B I have identified, it is magnesium, and C is zinc. Sodium, B magnesium and C zinc. Is that okay, students? Right. So then the third part of the question. Which metal out of A, B and C reacts rapidly with cold water? So A, B and C, sodium, magnesium and zinc. You can remember the reactions. Sodium, when you put a small piece of sodium into a large trough containing water, what happens? Sodium reacts violently with water. When we say violent, it darts on the surface of water. It gives a hissing sound because hydrogen is evolved and it produces sodium hydroxide, liberating hydrogen gas. So sodium hydroxide is a base. And we know that during this reaction, there is lot of heat evolved. That is why if we take small amount of water and put a large piece of sodium, because the reaction is violent and there is heat evolved, there can be explosion. So to prevent that, we use a large amount of water. So that is a violent reaction and it is a very fast reaction. Whereas magnesium, does it react? No. Magnesium doesn't react with cold water. But when we react it with hot water, what happens? It again forms the magnesium hydroxide and liberates hydrogen gas. And also magnesium reacts with steam. But when you hold it to the steam, we did not do that activity, but you all know the reaction. It forms magnesium oxide and hydrogen gas. Whereas zinc, iron, They don't react with cool water, they don't react with hot water, but they react with only steam, forming the oxide. So, sodium reacts fast with cool water. Magnesium doesn't react with cool water, reacts with hot water and steam. Zinc only reacts with steam. So, which metal out of A, B and C reacts rapidly with cold water? That is metal A. So, here we can either write it as metal A or we can write it as sodium because we have already identified it. I will leave it as metal A. So, with that students, we will move on to the next question. Part 4. Write the balanced chemical equation for the reaction of above metal with water. So, what was the metal? It was sodium. They want us to write the balanced chemical equation for that reaction. You are familiar with that. Now, when sodium reacts with water, what are the products? Sodium hydroxide and hydrogen gas. Sodium with water, NaOH and H2. Is it balanced? There is one sodium here, one sodium there. Two hydrogen atoms, but there is one hydrogen, two. So that means there are three hydrogen atoms. So it's not balanced. Then there is only one oxygen. Now since we have two hydrogens and three hydrogens there, what do we normally do? We make the number of hydrogens as 4. This is the inspection method, students. So we have to keep on looking at it with practice. Now you all know we need to make the number of hydrogens as 4. So to do that, we put a 2 here. So 2 hydrogens, altogether 4 hydrogen atoms. To balance that, you put a 2 here. So 2 into 2, again 4 hydrogens. If you check oxygen, 2 oxygen atoms. Here also 2 oxygen atoms. But sodium, there's only one here. There are 2 sodium atoms there. So what do we do for that? We put a coefficient 2 here. So 2 sodium with 2 water gives rise to 2 sodium hydroxide and 1 H2 gas. So that is the balanced chemical equation. And here they have said use standard symbol of the metal. So instead of writing it as A, this is how they expect us to write it. So I will leave it at that. Otherwise, normally what I would do is, I will write the correct equation because we are familiar with that. And then if they ask you to use the given symbol, you can substitute that and write. But here, of course, they have said use the standard symbol of the metal. That is sodium. Is that okay, students? So then, we'll look at the next part. Write the name of an O that contains metal D. Now, metal D, what is that? We identified it as iron. So, write the name of an O that contains metal D. Write the chemical formula of the compound. So, what is the O? We used it in the blast furnace to extract iron. Hematite. So, hematite is the name of the O. Hematite, and they want us to write the chemical formula. Chemical formula is Fe2O3. Fe2O3. So, hematite Fe2O3. Is that okay, students? So, then the next slide. Extra question 29. Observations of 3 tests carried out by a group of students to identify the gases collected in the laboratory are given below. So, they have collected some gases and the observations are given to us. Look at the observations. Flame was extinguished immediately when a burning splinter was introduced into a test tube with gas P. So, we collected 3 gases: hydrogen, oxygen and carbon dioxide. Hydrogen, you all know, it is a combustible gas. So, it burns with a squeaky pop sound or a pop sound. You were able to hear that during the activity. Then oxygen is a supporter of combustion. So, when you insert a glowing splinter, it relights and burns. Whereas carbon dioxide, it is a non-supporter of combustion. So when you insert a lighted splinter or a burning splinter, it is put off immediately or the flame is extinguished immediately. So the first observation, flame was extinguished immediately. So what will gas P be? That is carbon dioxide. So while you read the question itself, students, you should identify the substances that are given. Then it is easy. And if you write it down also, it's easier to answer the questions. Then the next one. The glowing splinter relighted when it was introduced into a test tube with gas Q. So relighted, supporter of combustion, oxygen. So this has to be oxygen gas. Then gas R burnt with a pop sound. So pop sound, immediately you know hydrogen. Pop sound when a burning splinter was introduced into a test tube containing the gas. So that will be hydrogen gas. So we have identified the three gases. The first question, identify the gases P, Q and R. So while you read, if you identify the gases, it's easy to answer the questions. So here, gas, first one P is carbon dioxide, or you can write it in words as carbon dioxide. Carbon dioxide. Then there is gas Q, that is oxygen. So here you can also write it as oxygen. You can either use the symbol, the chemical formula, or the word to denote the gas. Then gas R. R is hydrogen. Hydrogen. So from the observations, we have identified the three gases. Gas P is CO2, carbon dioxide. Gas Q is O2, that is oxygen. And gas R is hydrogen, H2 hydrogen. So with that, students, we look at the rest of the questions. Write the properties related to the combustion of the above gases. So I discussed that with the questions also. Carbon dioxide, non-supporter of combustion. Oxygen, supporter of combustion, and hydrogen, it is a combustible gas. That's why we use it as the fuel in rockets as well. It is a light gas, at the same time it is combustible. So that is what you need to write here. So here, of course, students, we can use the correct symbol and the name itself, the standard formula, chemical formula. So CO2, non-supporter of combustion. Then oxygen, supporter of combustion. Supporter of combustion. And hydrogen is a combustible gas. So carbon dioxide, non-supporter of combustion, oxygen, supporter of combustion, and hydrogen, combustible gas. So those are the properties related to combustion of the above gases. These can burn, this supports combustion, and carbon dioxide prevents combustion. That is why we use it in the fire extinguishers. And also because carbon dioxide can become a solid. I have explained that to you all before. When we have the CO2 fire extinguisher, when you spray it onto fire, carbon dioxide under high pressure, when it comes out as a solid. So that puts off fire. And that is possible because it's a non-supporter of combustion. Then the third one. A solution turns milky with gas P. Write the chemical formula of this solution. Now gas P, what is that? We have identified it as carbon dioxide. So carbon dioxide gives a milky color solution with what? With lime water. What is lime water? Lime water is calcium hydroxide. So a solution turns milky with gas P. Write the chemical formula of this solution. So the solution is calcium hydroxide. So here we can say calcium hydroxide. We also call it as slaked lime, and the chemical formula is CaOH twice. So they have asked the chemical formula of this solution. Why does it become milky in color? When carbon dioxide is passed into calcium hydroxide, it forms calcium carbonate and water. And calcium carbonate does not dissolve in water. That is why you get that milky color. But what happens if we continuously pass carbon dioxide? Then calcium carbonate, water and carbon dioxide react and they form calcium bicarbonate. Calcium bicarbonate is soluble in water. So because of that, after some time, when you continuously bubble carbon dioxide, the milky color is lost. The solution becomes colorless again. So that is the test to identify carbon dioxide gas. Then the fourth one, write the balanced chemical equation for the observation mentioned above. So that is the solution becoming milky in color. So I told you all the reaction. How do we write it? Calcium hydroxide, that is lime water, plus carbon dioxide gives rise to calcium carbonate plus water. So we need to balance it. Calcium, one atom. Then oxygen, there are 2 oxygen atoms and there are 2 oxygen atoms here. So 4. Here also 3 plus 1, there are 4 oxygen atoms. Hydrogen, 2 times. So there are 2 hydrogen atoms. Here also there are 2 hydrogen atoms. There is 1 carbon, there is 1 carbon there. So this is a balanced chemical equation. So write the balanced chemical equation for the observation mentioned above. Is this clear, students? So you should be familiar with the observation, why that happens, and you should know to write the equation as well. So with that, we'll move on to the next question. Part 5. Write 2 chemical substances available in the household that can be used to prepare gas R. So I'll check what gas R is again. Now we identify the gases. Now here gas P CO2, gas R QO2 and gas R is hydrogen. So we need to write 2 substances that can be used to prepare hydrogen in the household. Write 2 chemical substances available in the household that can be used to prepare gas R. What are they? Can you think of something? Usually when a metal reacts with dilute acid, we get hydrogen gas. There was a question earlier also where you have to fill hydrogen balloons in the household. So what can you use there? You all are familiar with aluminium. We get aluminium foil in the household. So aluminium is a metal and vinegar. What is vinegar? Vinegar is acetic acid. So aluminium with acetic acid will produce hydrogen gas. So we can use those two to do this activity. So here I can say aluminium or aluminium foil and vinegar. So this is the aluminium metal and vinegar is acetic acid. C. Acetic acid is CH3COOH. So that is vinegar. So if you take a piece of aluminium foil, break it into tiny pieces, you take a bottle and into that if you take vinegar and into that if you put these tiny pieces of aluminium, then you will get the hydrogen gas. Is that clear, students? So then, the 6th part. Write 2 uses of gas Q. So you're familiar with gas Q. What was the gas Q? We will check it again. Gas Q is the second one, that is oxygen gas. If we look at the question, write 2 uses of gas Q, that is O2 gas. So what are the uses of oxygen gas? Very important for us. We breathe, we inhale oxygen. So because of that, it can be filled into cylinders, and the oxygen cylinders can be used for patients who are in critical conditions, or it can be used by mountain climbers, deep sea divers, and also space travelers. So it can be filled into oxygen cylinders. Then it is a supporter of combustion. So for any combustion, we need oxygen gas. Then there are these acids, sulfuric acid, nitric acid. So if you want to manufacture these acids, we need to use oxygen as a raw material. So it can be filled into oxygen cylinders. It can be used as a raw material to produce sulfuric acid and nitric acid. Then also it is used for combustion. You can write any two of these uses. So here I can say filled into cylinders that can be used by patients, deep sea divers, space travel or travelers, and mountain climbers. Mountain climbers. That is one. Then if you like, you can tell about the combustion. I will write the manufacture of sulfuric acid and nitric acid. Used as a raw material for the manufacture of nitric acid and sulfuric acid. Nitric acid and sulfuric acid. So those are uses. So the uses of oxygen gas, students. Filled into cylinders that can be used by patients, deep sea divers. So here it should be deep sea divers. Then space travelers and mountain climbers. It's also used as a raw material for the manufacture of nitric acid and sulfuric acid. Like this, you can also say about the combustion. It is needed for combustion. Then it is required for breathing. So all those can be considered as uses. You can write any two of those uses. So I am sure, students, you would have written all these answers correctly. With that, I'll move on to the next part. That is extra question 30. A set of apparatus arranged by a student to collect a sample of hydrogen gas using an acid and a metal is shown below. So, they are collecting hydrogen gas using an acid and a metal. Look at the diagram. So, here it is a conical flask, and in that they have shown the metal. So, you know, usually we use either magnesium or zinc. Even aluminium can be used. We discussed it a little while ago. So, then acid, what are the acids that can be used? We normally use dilute hydrochloric acid or dilute sulfuric acid. Even like I said before, vinegar can be used. So, usually dilute hydrochloric acid or dilute sulfuric acid. Then D. What is D? It is a conical flask that you know. Then what is this apparatus? It is a thistle funnel. Thistle funnel is labeled as A. Then there is the stopper. Then you have the delivery tube that is labeled as B. There is the gas jar C. Is this diagram correct, students? Now this part is okay because thistle funnel has to be long. It has to come right to the bottom so that the gas that is evolved does not enter through the thistle funnel, and also the solution falls onto the metal easily. Then we have the delivery tube at a higher level. So that is also correct because hydrogen is a lighter gas. It will rise up enter into the delivery tube and will be collected. What about this part? Is it correct? No. Why? Because hydrogen is a lighter gas or the lightest gas. So it can be collected by the downward displacement of air. Now what is shown here is the upward displacement of air. So this part is a mistake. So I have told you all before also, when they give a setup like that, if they draw something wrong or if they have a mistake in the diagram, that means they will ask you questions related to that. So this part has a mistake there. It should have been the other way around. We will need to have the gas jar like that, and the delivery tube will be sent in like this through here. So the hydrogen gas will go up, hydrogen will go up, and air will be pushed down or displaced down. So that will be downward displacement of air. So that is how we need to have the correct setup. So then we look at the questions. First one, identify A, B and C. What is A? Thistle funnel. What is B? Delivery tube, and C? Gas jar. So A, thistle funnel, then there is B. B you can see there, students, it's the delivery tube. Then there is C. Here C is the gas jar. And D is labeled here, that is the conical flask. So thistle funnel, delivery tube, gas jar and conical flask. So those are the parts or apparatus labeled as A, B, C and D. Then the second one, write 2 errors that can be seen in the above setup. So I already explained the 2 errors. What are they? The gas jar should be turned upside down. The gas jar should be turned upside down so that air can flow out from the bottom. So that is one mistake. The gas jar should be turned upside down. It is kept the straight way, the normal way, but it should be turned upside down. Then write the second error. What is that? The delivery tube has been sent from the top into the gas jar. So, but it should have been sent from the bottom. So, there we can say the way the delivery tube is connected is wrong. It should be inserted from the bottom of the gas jar. So those are the 2 mistakes, students. Even the first one, you can say the gas jar. Here I have written it as jar. It should be gas jar should be turned upside down so that air can flow out from the bottom. So this, of course, there is a mistake. If you want, you can write it as the gas jar has been kept the normal way. That is the mistake. And then you can write this correction. And the second one, the way the delivery tube is connected is wrong. So it should be inserted from the bottom of the gas jar. So I have written the mistake and the correction as well. So those are the answers for these questions. There are a few more parts there. I'll move on to the next slide. Third one, name an acid and a metal that can be used in this activity. So already I told you all it can be dilute hydrochloric acid or dilute sulfuric acid and magnesium or zinc. So I will say dilute sulfuric acid, and zinc, the metal. Name an acid and a metal that can be used in this activity. Then the fourth one, write balanced chemical equation using the metal and acid you mentioned above. So the metal and the acid we have mentioned above, dilute sulfuric acid and zinc. Zinc plus H2SO4 will give rise to zinc sulfate plus H2. So they are zinc, H2, sulfate. So that is a balanced chemical equation. Zinc plus sulfuric acid giving rise to zinc sulfate plus hydrogen. Then the last part. And also students, you all know if you take magnesium, it also reacts in the same manner with sulfuric acid. Here you will get magnesium sulfate evolving of hydrogen gas. If you take hydrochloric acid, then what will be the difference? Zinc plus hydrochloric acid, you will get zinc chloride and hydrogen gas. Same way magnesium plus hydrochloric acid, magnesium chloride and hydrogen gas. You are familiar with all those reactions, students. So according to what you write here, you will need to write the balanced equation there. Then the last question. State a test and the relevant observation to confirm that the gas produced by the reaction is hydrogen. So what is the test? You insert a burning splinter into the test tube containing hydrogen gas, and if it burns with a pop sound, we can confirm that it is hydrogen. So they want you to write the test and the relevant observation. So there you can see test, insert a burning splint or burning splinter into a test tube containing H2 gas. Then what is the observation? Observation, it burns with a pop sound. So that is very important. You have to say pop sound or squeaky pop sound. Either one is correct. So it burns with a pop sound. So then we can confirm that the gas is hydrogen. So test, insert a burning splinter into a test tube containing H2 gas, and the observation will be it burns with a pop sound. Is that clear, students? So I am sure, students, you all were able to answer all these questions correctly, and you were able to understand my discussion as well. So with that, students, I have completed this chapter and the lesson itself. So we discussed the changes of matter. Under that we have discussed chemical changes, physical changes, then the chemical changes, under that all the 4 types of reactions, and then how different metals react with different substances, oxygen, water, acids, and also the displacement reaction. Thereafter we arrange the metals into activity series. Then from there we discuss the uses of activity series, and then we discuss the extraction of metals, that's iron and gold. Then we discuss the preparation properties and the uses of 3 different gases, hydrogen, oxygen and carbon dioxide. And related to all those, I have discussed the questions given in your textbook and all these extra questions. So with that, students, I have completed this lesson.